Recall that in our discussion of the vertical line test, we said that all x's are used should be carefully tested if the graph is like this. Why? Because up until this part and up until this part, these x's here are the only ones to be considered. The x values are here and here should not be considered because they are not part of this relation's domain. Remember, we have encountered domain as in our relations and functions. If we represent the relation or the function as a mapping, this first set here is our domain. Also, in our set of ordered pairs, such as this one, we would say that these numbers are the elements of our domain. To formally define domain, it is most commonly used to describe the set of values for which the function is defined. What do we mean by this? When we say the function, or let me add the relation even, is defined, it means the function or the relation exists. For example, if we take a closer look here at this rough sketch of our graph, there we go. Here, we can see that our relation is only up until these parts of the x, meaning these are the ones that are only part of our domain. Which would mean that beyond these values of x, the function or the relation is not defined. Meaning the relation does not exist with these values of x's here. And that is what the domain is. These are the values that would only make our relation or function exist. If a specific x is not part of the domain, even though it's in the Cartesian plane, the function will not exist with that specific value of x. Now, determining the domain is usually associated with the equations and graphs of functions. So we have here our 4 functions. Now, do take note of the following. We learned that from grade 8, we have our linear function. Grade 9, we have our quadratic function. And then in grade 10, we learned that both of them are actually part of a big family called the polynomial functions. And their domain would be the set of real numbers symbolized by double R, double capital R for that matter. There we go. So that means numbers 1 and 3, y equals 2x plus 1 is linear function. Y equals x squared minus 2x plus 2 is a quadratic function, and both their domain should be written this way. D, which is usually our symbol for domain, is equal to the set of all x, such that x is an element of the set of real numbers. This is how we write our domain in set notation. We can also simply write the domain is equal to double R, because the double R itself means set already, set of real numbers. So there we go. So again, if our function is linear, quadratic, or polynomial, therefore our domain will automatically be the set of real numbers. How about for functions such as number 2? Our function is y is equal to the square root of x plus 1. And usually we would call this function the square root function. And do take note that square root functions, their domain would be whatever the inside the square root symbol is called the radicand we should solve it so that it would be greater than or equal to 0. For example, for this specific one, we should have x plus 1 is greater than or equal to 0. And just like solving linear equations, all we need to do is transpose. Therefore, we'll have x is greater than negative 1. Therefore, the domain is equal to the set of all x such that x is greater than or equal to negative 1. So let's say we have another square root function, y is equal to the square root of 2x minus 5. Pause the video and try to find the domain of this specific function. So to find the domain of this function, we take this, the radicand. 2x minus 5 should be greater than or equal to 0. And just like solving an equation, we transpose it here. Therefore, we'll have 2x is greater than or equal to 5. Divide both sides by 2. X now will be greater than or equal to 5 halves. Our final answer now will be the domain is the set of all x such that x is greater than or equal to 5 halves. And for functions that are fractions, like this, we call them rational functions. And for their domain, we have to make sure that the denominator, that their denominator is not equal to 0. So such as this one, we have to make sure that x minus 1 is not equal to 0. That means we should first solve what is x minus 1 equals 0 is. So we just transpose and we will have x equals 1. Then bring back the not equal sign. So therefore, the domain of this function would simply be this is equal to the set of all x such that x is not equal to 1. Let's have another example. What if our function is y is equal to x minus 1 over x plus 1? Pause the video and find the domain for this function. So, what we will do, we'll have x plus 1 is not equal to 0, but we shall just make it x plus 1 equal to 0, transpose, therefore we'll have x equals negative 1. Bring back the not equal sign. Our final answer for the domain will be the set of all x, such that x is not equal to negative 1. And that is how you find the domain of functions.